Hello everybody. Today I'm going to be talking about rational functions and their graphs. So let's get started with the meaning or the definition of rational functions. So what's the meaning of rational function? Let's say rational function r of x is p of x over q of x, where p of x and q of x are polynomials. So simply, the rational function is a polynomial over polynomial. Okay, now since we have denominator here, we need to make sure that the denominator is not zero. So if the denominator is zero, we're gonna have a problem, because in mathematics, if we have 3 over 0, this is unknown quantity, this is undefined. Okay, but if it's 0 over 3, it is 0, so it's okay. But 3 over 0, it's undefined quantity, so this is a problem in mathematics. So we need to avoid this problem by putting this restriction. We need to say that q of x is not 0. Okay, let's take this example to see what I mean. Let's say r of x equals to x plus 4 over x minus 3. Now in this situation, the denominator is x minus 3. We need to check the values of x that make the denominator 0. So take the denominator and make it equals to 0 to check when the denominator equals to 0. So we formed this equation. Now solve it. Solve for x. Make x subject to formula. So add 3 to both sides. You're going to get x equals to positive 3. Now when x is a 3, the denominator is going to be 0, and we're going to get undefined quantity. So let's check this out. Let's substitute in the function r of x. Let's find r of 3. So it's going to be 3 plus 4. We're substituting in this function. We're replacing x by 3. So 3 plus 4 over 3 minus 3, which is 7 over 0, which is wrong, undefined. Okay, so again, x equals to 3 causes a problem. Why? Because x minus 3 is in the denominator, and when you substitute 3 instead of x, you're going to get 0 in the denominator. So this point, when x equals to 3, we call it point of discontinuity. So x equals to 3 is a point of discontinuity. All right. Let's take another example. Let's say we have f of x equals to x plus 1 over x squared minus 4. Now, what's the denominator in this situation? It's squared x minus 4. So make it equals to 0 to find the problems, the values of x that cause problem. So add 4 to both sides. So squared x is going to be 4. Now take square root to both sides, and don't forget positive or negative. So x is going to be either negative 2 or x positive 2. So here we have two values. If we substitute these two values in the function f of x, you're gonna get 0 in the denominator. So these 2 points are called points of discontinuity. Okay? Now, since these 2 points are points of discontinuity and they make problem, okay, we need to avoid this problem by excluding these values from the domain. And remember, the domain is all the values of x. Okay, so by excluding these two values, it will be there will be no problem. Okay, so the domain in this situation, domain of f of x, it's gonna be all real numbers except -2 and +2. And here in R of x, the domain will be all real numbers except the point of discontinuity, which is 3. So except just 3. Okay, now points of discontinuity, okay, is divided into two parts: removable and non-removable. Removable and non-removable point of discontinuity. Now, to know the difference between them, let's take this example. Let's say we have h of x equals to x minus 1 multiplied by x plus 3 over x plus 3 multiplied by x minus 4. Now in this situation, we have 2 points of discontinuity. From this, x plus 3, we can get that x equals to -3. This is the first point of discontinuity. And from the second one, we get x equals to +4. This is the second point of discontinuity. But if you notice, we have numerator which sharing the same expression x plus 3, and we have here x plus 3. So in this situation, we can remove x plus 3. It's gonna be cancelled from the denominator and the numerator. So x plus 3 from the denominator, it's gonna be removed. So there will be no problem with x equals to -3 because it's gonna be removed. So in this situation, the point of discontinuity x equals to -3 is called removable. Why? Because we managed to remove x plus 3, and the function h of x is going to be x minus 1 over x minus 4. So in this situation, x equals to -3 is called removable. And because we're still having x minus 4 in the denominator, okay, so it is non-removable because we couldn't remove it from the denominator. So x equals to -4 is called non-removable. Okay, now let's go back to the title. Here we talked about the rational function, and now we're going to be talking about the graphs of the rational function. Now, the graphs of the rational functions. Now we have two types of the graphs. There continuous graph and there is discontinuous graph. Now continuous graph is a graph in general. It's the graph that we don't remove our pen or pencil while we are drawing it. So it's gonna be continuous like this. But the discontinuous one, there will be gap or hole or something like this. Okay, now in the rational function, okay, we're gonna have a continuous graph if there is no point of discontinuity. Okay, like for this example, f of x equals to x plus 3 over x squared plus 1. Now dealing with the denominator, squared x plus 1 equals to 0 to check when we have a problem here. Okay, subtract 1 to both sides, so squared x is going to be -1. Now there's no real number. If you square it, the answer will be -1. So in this situation, this one has no solution. That means there is no point of no value of x that makes denominator 0. So in this situation, there is no point of discontinuity. So the graph of this function f of x will be continuous. But if we have point of discontinuity, the graph of the function will be discontinuous. And since we have two types of point of discontinuity, okay, there will be two types of discontinuous graphs. If we have removable point of discontinuity, the graph will have a hole. And if the point of discontinuity is non-removable point, the graph will have a gap. So I'm gonna explain now what's the difference between them. So let's start with graphing a graph with a hole. Okay, so keep in your mind we have to have a removable point of discontinuity. So let's take this example to see what I mean. Let's say y equals to x plus 1 multiplied by x minus 3 over x plus 1. Now, if you notice, the denominator in this situation will be removed because we have x plus 1 in the numerator. So the function will be x minus 3, where x can't be negative 1, because here the denominator is x plus 1. We make it equal 0, so the point of discontinuity is x equals to negative 1, but it is removed because we have x plus 1 in the numerator. So in this situation, the rational function, okay, has point of discontinuity x equals to negative 1, and this point of discontinuity is removable. And since we have a removable point, the graph will have a hole. So how to graph a hole? Okay, now to graph any line, if you notice, the function here is a line, okay, but not any line, it's a special line because it comes from a rational function. Okay, so this line this line has a restriction. The restriction is x can't be negative 1, so we need just to exclude this point from the graph, so it will be a hole on it. So let's check this out. Now, to graph any line, we need x-intercept and y-intercept, or you can choose any any 2 points you want, because to graph any 2 points, to graph any line, you need 2 points, and once you plot these 2 points, you can connect them to get the line. Okay, so the easiest way to graph the line is to find the x-intercepts and the y-intercept. So let's find the y-intercept and the x-intercept of the function y equals to x plus 3. So let's start with finding the x-intercept. Now you all know that x-intercept is the point of intersection with the x-axis. So on the x-axis, the value of y will be 0. Okay, so substitute here in this function, okay, y equals to 0. So it's going to be 0 equals to x minus 3. Here, I'm substituting in this equation, and I replaced y by 0. So we've got this equation. Now solve it by adding 3 to both sides. X is going to be positive 3. Now remember, this is the x-intercept. This is not the point of discontinuity. This is something else. Okay, now the graph or the line y equals to x minus 3, it's gonna intersect the x-axis at x equals to 3. Now let's find the y-intercept. The y-intercept is the point of intersection with the y-axis. So the y-axis, any point on the y-axis, has coordinates with x equals to 0. So we need to replace x by 0. So again, I'm replacing in this function. So y equals to 0 minus 3, which is negative 3. So the y-intercept, it's going to be y equals to negative 3. Now let's draw the x-axis and the y-axis. And here we're going to have the y-intercept, which is negative 3 to 3. So this is negative 3. And the x-intercept, which is 3. Here. Now just connect these 2 points to graph or sketch a line. But remember, this is not any line. This is a special line with a restriction. we have a restriction here, which is x can't be -1. Now we need to know this point where will be a hole on it. Okay, so the coordinates of this point is -1 and something. Now what's the value of y? We need to substitute -1 here in this function. Okay, so y equals to -1 minus 3. We replace this x by -1, and we've got y equals to -4. So that means there will be a hole, okay, when x -1 and y -4. So go to the graph and plot this point, -1 and -4. So this is -1, and on the y-axis this will be -4. So corresponding is gonna be here. So here we're gonna have a hole. So this hole, when you connect the line, it's gonna be in this way. Okay, so simply we're gonna have a line, straight line, but this part it's gonna be removed because this at this point, specific point, which is when x equals to -1, the function will be undefined, because if you go back to the original function, okay, x plus 1 is in the denominator, so when x equals to -1, the denominator will be 0 and the function will be undefined. So that's why there will be a hole here. So remember, we are talking about discontinuous graph when we have a hole. Okay, now let's talk about the gap. Okay, so let's say we have this function y equals to x minus 3 over x minus 2. Now what's the denominator? It's x minus 2. Now x minus 2 equals to 0, so we have point of discontinuity when x equals to +2. And if you notice, there is no x minus 2 in the numerator, so x minus 2 in the denominator is not removed. So in this situation, this is non-removable. Non-removable. And since we have non-removable, the graph is gonna have a gap. So to graph the gap, it will be a little bit different than when we graph a rational function with a hole. Okay, so let's see how to graph this. Okay, again we're gonna need x-intercept and we're gonna need y-intercept. So let's start finding them. To find x-intercept, replace y by 0. So it's gonna be 0 equals, I'm substituting here, okay guys, this one. So this becomes x equals to x minus 3 over x minus 2. Now 0 over 1, do cross multiplication, you're gonna get x minus 3 equals to 0. So solve for x is gonna be +3. This is the x-intercept. Now do the same thing, but instead of replacing y by 0, replace x by 0 to get the y-intercept. So y is gonna be 0 minus 3 over 0 minus 2. Again, I replaced x here, okay, and x in the denominator by 0. So the result is gonna be -3 over -2, which is 3 over 2, 1.5, 1.5, whatever you want. But keep in your mind, it's positive value. Alright, now if you notice, we did exactly the same here. We found the x-intercept and the y-intercept. But here, if we have a gap, we need to find two more things, which are the horizontal asymptote and a vertical asymptote. So let's start with the vertical asymptote because it's much easier. Now to find the vertical asymptote, we need to just take the point of discontinuity. Now we have here one point of discontinuity, which is x equals to +2, which is the denominator. Okay, so simply the vertical asymptote is going to be x equals to positive 2. This is the vertical asymptote. Now we need to find the horizontal asymptote. Now to find the horizontal asymptote, actually we have some rules. So let's study these rules and let's go back to this function to solve it. Okay, so the rules are, to find horizontal asymptote, okay, you need to know that the degree of the numerator is n and the degree of the denominator is d. Okay, since we're talking about, guys, rational function, remember r of x is p of x over q of x. Do you remember the beginning of this lesson? We said it's a polynomial over polynomial. So any polynomial has a degree, and the degree of the polynomial is the highest power. Okay, so for example, if we have x squared x plus 3x, the degree of this function or the polynomial, okay, is 2, because 2 is the highest power here. Okay, now the degree of the numerator is n and the degree of the denominator is d. Now let's study these rules and let's go back to that question. Now if n is less than d, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote will be the x-axis, which is y equals to 0. If the second rule, if the degree of the numerator equals to the degree of the denominator, the horizontal asymptote will be the coefficient of the numerator over the coefficient of the denominator. Okay, if the degree of the numerator equals to the degree of the denominator, we take the coefficients. Like for example, if we have 3 squared x over 4 squared x plus x, here we have same degree, 2, 2. So in this situation, the degrees are equal. So we take the coefficients of the leading terms. So the horizontal asymptote will be 3 over 4. So the horizontal asymptote will be 3 over 4. Okay? Now, the third rule says if the degree of the numerator more than the degree of the denominator, there will be no horizontal asymptote. And we're going to be talking about this later. Now, let's go back to our example to see which situation it's going to be satisfied. Now, the degree of the numerator here is 1. And the degree of the denominator is 1 as well. So in this case, we need to go to the second rule, okay, and since they are equal, we need to take the coefficients of the numerator and divide it by coefficient of the denominator. Okay, so here the coefficient is 1 and the coefficient of the denominator is 1 as well. So in this case, the horizontal asymptote will be y equals to 1 over 1, which is 1. So this is the horizontal asymptote. Okay, now again we've got the x-intercept, y-intercept, the horizontal asymptote, and the vertical asymptote. Now we can graph it. So please concentrate. Let's graph this function y equals to x minus 3 over x minus 2. Again, make x-axis and the y-axis, and let's sketch it. Let's start with the horizontal asymptote, which is y equals to positive 1. So this is a horizontal asymptote, y equals to positive 1. And the vertical asymptote equals to x equals to positive 2. So this is positive 2. So make a vertical asymptote. So this is x equals to positive 2. Okay, so it's like we're graphing a new x and y axis. Okay, all right. Now plot the x-intercept and y-intercept. But before that, you need to know something. Look, now the graph of the rational function with a gap will be one of these two cases. Either it's going to be something like this, okay, or it's going to be in this way. So what's the thing that determines this? Simply the x-intercept and the y-intercept, or you can choose any point you want below x equals to positive 2 or after x equals to positive 2 to check the location of the point. Okay, so I want to choose the x-intercept and the y-intercept to determine the shape of the graph. Okay, now the x-intercept will be 3, so it means the graph will intersect the x-axis at a 3. So that means the point will be here. It will be located here. So immediately the graph will be something like this, guys. Okay, so to make sure that it's like this, let's see where is the y-intercept. The y-intercept is y equals to 3 over 2. And we know that 3 over 2 is more than 1. So it's going to be above the horizontal line, which is y equals to 1. So it's going to be here, 3 over 2. So that's clear that the graph will be like this. Let me just fix this. It's gonna be something like this. Okay guys, let's solve this example. We need to sketch y equals to squared x minus 4 over squared x plus 3x plus 2. Now, the first step we need to do is to factorize the numerator and the denominator. So the function will be y equals to x plus 2 multiplied by x minus 2. This is the difference between two squares. And the numerator is going to be, the denominator will be, product of two numbers is 2, and the addition is positive 3, so the two numbers are 2 and 1. So it's going to be x plus 2, x plus 1. Okay, now if you notice, we're going to have a removable point of discontinuity, which is x equals to negative 2. This is removable. So that means we're going to have a hole when x equals to negative 2. And we're going to have here x plus 1. This point of discontinuity, negative 1, okay, is not removable. This is non-removable. Okay, so in this situation, we're going to have a gap. Okay, now to graph this mixed question, let's say mixed question because we have hole and gap at the same time, you need to start graphing the gap. Okay, so remember, we need to find the x-intercept, y-intercept, and the horizontal asymptote and the vertical asymptote. Okay, so let's start with the x-intercept. But before that, let's just simplify this function. So y equals to x minus 2 over x plus 1. So the function y becomes this. Okay, now let's find the x-intercept and the y-intercept. Alright, now the x-intercept will be, place y by 0, so it's going to be 0 equals x minus 2 over x plus 1, and if you notice, we always ignore the denominator in the situation because we multiplied by 0. So it's going to be x minus 2 equals to 0. Solve for x is going to be positive 2. So again, this is the x-intercept. Please guys, don't mix it with the removable and non-removable, the point of discontinuity. Okay, this is the x-intercept. This is where the function intersects, or the graph intersects the x-axis. Okay, this is not the point of discontinuity. Okay, now to find the y-intercept, replace x by 0. So it's going to be 0 minus 2 over 0 plus 1, which is negative 2. So the graph will intersect the y-axis at x equals to negative 2. Now we just found the x-intercept, the y-intercept. Now let's find the horizontal asymptote and the vertical asymptote. The horizontal asymptote is, look at the degree of this function, y equals to x minus 2 over x plus 1. Again, we have here 1, the degrees the same, so we take the coefficients, so it's going to be y equals to 1 over 1, which is 1. And the vertical asymptote, simply the point of discontinuity. And wait, here we have 2 points of discontinuities. The first one, x equals to negative 2. The second one, x equals to negative 1. So which one should we choose, or should we choose both of them? Since the x equals negative 2 is removable, we don't choose it, because this one, okay, it's gonna have a hole. But the one which is non-removable is when x equals to negative 1. So just we take this one. So the vertical asymptote will be in this situation negative 1. But guys, keep in your mind, it doesn't mean the vertical asymptote will be always 1. Okay? So number of vertical asymptote is not always 1. Okay? We're gonna have 2 vertical asymptote, which is we're gonna be talking about it the next video. Okay? Now, going back to this function, y equals to x minus 2 over x plus 1, we just found the horizontal asymptote and the vertical asymptote. So now we are ready to graph or to sketch the function y. Okay guys, let's graph this one. Now we have x-intercept, y-intercept, the horizontal asymptote, and the vertical asymptote. Now let's start by drawing the horizontal asymptote and the vertical asymptote. The first one, horizontal asymptote, y equals to positive 1. So this is y equals to positive 1. Make a horizontal asymptote here. This is the horizontal asymptote, y equals to positive 1. Now the vertical asymptote, x equals to negative 1. So go to the x-axis, this is the point x equals to negative 1. Make a vertical asymptote, x equals to negative 1. Now just we need to know which side we're gonna be graphing, either this one and this one, or this one and this one. So which one decides, or which one determines? We need to check the x-intercept and the y-intercept. Okay, so the x-intercept is positive 2, so it means it's gonna intersect the x-axis at positive 2 here. Okay, and the y-intercept, it's gonna be negative 2, so in this situation it's gonna intersect the y-axis at negative 2. So simply it's gonna be in this region and this region. Okay, so we're ready to graph now, but before that you need to keep in your mind we have a hole when x equals to negative 2. So we need to know the location of this point. Okay, so substitute x in the function y equals to x minus 2 over x plus 1. We need to replace x by negative 2 to find the location of the hole, because remember, any point, or hole, it's like a point. So any point has coordinates x and y. So we know the value of x, we need to find the value of y by substituting in the function. So replace x by negative 2. So when x equals to negative 2, y will be negative 2 minus 2 over negative 2 plus 1. So it's going to be negative 4 over negative 1, which is positive 4. Y equals to positive 4. So the point, or the coordinates of the hole will be negative 2, positive 4. So let's go back to the function and make a hole when x equals to positive 2, when x is negative 2 and 4. So this is negative 2 and 4. 1, 2, 3, 4. So it's gonna be, there will be a hole here. Okay, so just let me remove this and this one and graph. This one, it's gonna be approaching the vertical and the horizontal asymptote in this way, and keep in your mind it will never intersect the vertical asymptote. Okay, and here it's gonna be something like that. Okay, and it's a sketching, so it's not so accurate, so but it's gonna be something like this. And remember, it will never pass through the vertical asymptote. It will never. So simply it's gonna be approaching it. So if we fix it, it's gonna be something like this. Okay, just approaching but never passing through the vertical asymptote. So this is it. We have a gap and we have a hole at the same time. That's why we have 2 points of discontinuity with non-removable and removable ones. Okay guys, so this is it for this video. The next video I'm gonna be talking about if we have 2 points of discontinuities and these 2 points of discontinuity are non-removable. So in this situation we're gonna have 2 vertical asymptotes. Okay, bye for now and see you later.